So, properties of linear relations. First of all, we want to do a linear check. So, linear means straight line. So, does the function or the relation make a straight line? So, what you can do, number one, is you can graph the points. And check. Does it make a straight line? The other thing you can do, if you're given the equation, is can it become y equals mx plus b? This allows you to see that it has a constant rate of change. So that is a big indicator, having a constant rate of change of a linear relation. If it's constant, that means your slope stays the same throughout. So you'll get a linear relation. Now you have to be careful because you can get some like y equals 3 and x equals 2. These ones are linear. Okay, so they're not y equals mx plus b, but they do make straight lines. So just be aware, yes, there's two exceptions to the rule. Now, constant rate of change, you can check that if you're given the points. So if you're given the points, you can quickly find m to see if it's a constant rate of change. We're going to do that throughout here as well. So there's a few different things that you can do. You should be able to graph, and see. So for the first one, we have y equals 5x plus 1. That meets y equals mx plus b. So yes, it is linear. But you need to practice graphing because our next unit is all about graphing. I want you to make a quick little axes, graph that equation. So plot your plus 1 and then count with your slope. Okay, so do that now. Graph that equation. Okay. So plus 1, it's right here. 5 means you count up 5. 1, 2, 3, 4, 5 over 1. There's your other point. There's your line. Okay. So just a real quick check. You all need to know how to graph that really easily. Now the next one's a little bit different. You have x, y together. So how do you get rid of this multiplication that you see? Got to divide. So divide it by x. So y equals 6 divided by x. That's weird. We've never seen this before. Ever. What can we do to help us figure out what the graph looks like? Find some points. 3, 2, 1, 0. Now I kind of know what this graph looks like. Okay. Substitute it in. What's 6 divided by 3? 2, right? So y equals 6 divided by 3. 6 divided by 2. 6 divided by 1. What's 6 divided by 0? Really? Trying to calculate it because you just got 3 marks off. It's undefined. That's a little weird. So what I want you to do is plot those points on a quick grid. Keep it simple, nothing fancy. Just quickly plot those points. 3, 2, 2, 3, 1, 6. So what happens with this graph, this is one of those special graphs, and you get really close to x equals, you get really close to x equals 0, but you don't quite get there, right? It stays really skinny along the line. Okay, so this is not linear. You can see that by the graph, but you can also see it because the equation is not mx plus b. So it's not linear because of the format of the equation. Try the next one. First of all, look at it. Do you think it's linear? Why? Why is it not linear? Mx plus b? No, there's no exponent 2, folks. So right away you know it's not linear. In fact, these ones make your U shape. Okay? It's a parabola. So we have an x and a y. Let's do -2, -1, 0, 1, and 2. Find your y values. Go. So plug it into the equation. This will be 9. This will be 0, 1. Sorry, -1 minus 1 is -2. This will be 4. This will be 0. This will be 1. So if you graph that real quickly, you're looking at -2, 9, -1, 4, 0, 1, 1, 0, 1, 1. And if you did some more points, you would see you get this U shape going on. Whoops, nice U. Okay, so you know it's not linear, and you can graph that and see. So anytime you have an exponent 2, you're making a U shape. Do you know what an exponent 3 makes? No. Like that. Or sometimes they're even more. It's like that. Depends on what you put in there and stuff. Don't need to know that though, okay? Sorry? Yeah. When you get waves too, like you can graph sine and cosine, they all look like that, waves. That's later though, grade 12. Okay. Okay, next one. Guess what? That's general form. I guarantee you can turn that into y equals mx plus b. So go ahead and do it right now just to prove that you can make it a straight line. Okay, turn to y equals mx plus b. Use your algebra skills. Move the 6 or -6 and move the plus 5x. So you should get y equals -5/3 x plus 2. Please graph that. Check our graphing skills. They're going to be really important next unit, because we have to see where two lines cross. Okay, so quickly graph. So count down 5, right 3. There's your line. Okay. Yeah. Pardon me? Yeah, because it's a completely wrong line. You graphed a positive 5/3 slope. Right? It's a negative, so the negative sign either has to go down. That's fine, but then you go down and so you go up, but then you go left. Right? Up and left if it's a -3. Okay, now these points here, we don't have to put them into y equals mx plus b. We are going to do and see if we have a constant rate of change. So we're going to figure out, what does m equal? Well, it's rise over run. That's on your data booklet, and so it's y over x. So let's check our y values. What are we going up by? For each jump on our y values, what are we going up by? 5, 5, 5, 5. So that's your y values. Then check your x values. What are you going up by each time? 2, 2, 2, and 2. So your slope is 5 over 2. Okay? So it's constant. Each number was a 5 and a 2. So this means that it is linear. Okay? That's what we're looking at with the points. All of them were the same. Okay. Real quickly, I want you to graph x equals 6. You guys should be experts by now. And I also want you to graph y equals -2. Okay, do those two graphs, then you can see if they're linear. Okay, so x equals 6 is right here. And y equals -2 is right there. So these are both linear. So there's one exception to our y equals mx plus b rule. Okay. Any questions? How many people graph those? No problem. How many of you are lying? Okay, you should be able to graph those quite easily. Okay, this next one's a little weird. Paintings, they appreciate. Some investments always appreciate. So appreciate means it goes up by 8% each time. So what we can do is have time and value as in our chart, and we can see what happens. Time 0, the painting's worth 10 large. Okay. Now in 1 year, it goes up 8%. So 10,000 times 8% is a decimal. Okay, remember 8% percentages must be decimals. That equals 800 bucks. So it goes up by $800. So in 1 year, you're at 10,800. So 10,800 times 8%, because now the value is higher, it goes up by 8%, but it goes up by more than 800. So take your calculator, 1080, 800 times 0.08, 864. So now, after 2 years, you're at 11640. Is that right? That's not right. 1664. There we go. Is that right? Yeah. So to go for the 3rd year, you're going to take a more or a higher valued painting and go up by 8%. So this year, you're going to increase by more. And that's where the trouble is. You're not going up by a constant amount. Each year, you're going up by more. $12597 and 12 cents. So your rate of change started at 800, then went up to 864, then your rate of change went up to $933.12. So it's not a constant rate of change. Now that's for appreciation and depreciation. And of course it must be a percentage. Okay, so going up by percentages. So you look at your car. How many of you are looking to buy a car in the next couple of years? Probably, eh? So when if you go to the car lot and buy a $30,000 car, as soon as you drive it off the lot, you lose like $5,000. Do you guys know that? 5G, just like that. So what happens is your car's value goes down sharply. And eventually, after a few years, it steadies out at a used car price. So when you go to buy a car, you don't want to buy a car in this range because you're losing a lot of money fast. What you want to do is get a car somewhere down in this range. So it's still going to be quite good. You're not going to make a lot of repairs, but then you're not going to lose a lot of money. Now, of course, after like 12 years, well, then you're going to be paying a lot of money for repairs. So a good range for you guys and for everyone is to get a car somewhere in that range. Right? You're not going to lose a lot of money, but you're still going to have a car that runs well. Of course, you got to research the type of car. And you can totally do that online with Consumer Reports and all that. Don't buy a lemon. Right? Some years are bad years. But if you're buying it up here, you will be losing money, and that makes you a person that loses money. Okay? So, don't buy a car in that range. But again, this is more for desire. If you got money to burn, that's probably what you're going to do. Anyways, enough speech. So appreciation, depreciation, they are not linear. Why is my computer doing that? Something is funny. Hey, find your rate of change. Tell me if it's linear. Going up by ones each time for the x's. What about the y's? Going up by 3, 4, 5. Whoa! Your rate of change is changing. So it's not a constant rate of change. Okay. Therefore, it is not linear. Now, what we were asking before was whether it's a function or not. It's a completely different question. Okay, entirely different question to decide whether something's a function. So those are two questions you got to ask. In order to be a linear function, it must meet the output and input requirement, and it must also meet the y equals mx plus b requirement. Okay, so there's two things there. Any questions? Okay, turn it over. So now we're going to interpret graphs again. So this is going to be a little bit easier. So have a look. Here's the graph of that radio-controlled plane. Okay. Height, that's in meters. Time is in minutes. What does the slope represent? So m equals rise over run equals y over x. And for us, it's going to be height over time. And the units would be meters per minute. So you can also write it in this format as a sideways per sign. Well, what does that mean, folks? What does it represent? It represents the change in height per second. Or you could also say each second. Okay. Now you got to be careful here. For your slope, okay, a positive slope refers to an increase, and a negative slope refers to a decrease. So you need to make sure you use those types of words in your description. Navjeet?
Wouldn't it be the change in height per minute?
Ah, darn it. Yeah. So change in height per minute. Okay, or each minute. Thanks. Okay. So, find the plane's rate of change between B and C. What's your rate of change right there? 0 meters liters per minute. Okay, so there is no rate of change. So you're not going up or down. Is the plane still flying or is the plane stopped?
Still flying.
Yeah, it's still flying. Don't get tricked by that, okay? Good. Next one, what does the negative rate of change mean between C and D? So here we go down, -2, and we can go over 1, 2, 3, 4 minutes. So the rate of change is -1/2 meters per minute. So what does that mean? Yep. Exactly. So it means you're descending. And specifically it means you're descending 1 meter every 2 minutes. Okay? So you're going down by a rate of 1 meter per minute. Sorry, 1 meter per 2 minutes. Okay. Now you can also use the word each there. Okay, but each wouldn't be right for 2. But if it's a 1, it would. Okay. Yep.
Would rate and constant as well?
Yeah, you could. Yeah, because it's constant, right? There's a constant decrease. Yeah. Wouldn't be looking for that specifically, though. We'd be looking for just the word descending or decreasing. Okay, so you could use it, say, decrease as well. What's the opposite of descend? Do you guys know? Ascend with an A, right? So we've seen that before. Okay, find the average vertical speed. So the average vertical speed, what you need to do is draw a straight line from A to D. So here's A to D. What is the slope? Because remember, your slope is the speed. Right? Meters per minute, that would be the speed. Sorry, please write that up here for A, speed, meters per minute. Okay, so you're going up 1, 2, 3, 4 meters. That's happening over 9 minutes. So that means the speed is 4 over 9 meters per minute. Okay, 4 over 9 meters per minute. Next, calculate the change in vertical speed between the first ascent. So figure out the slope as they're going up between A and B. And its final descent, so the slope between E and F. Find those two slopes, please. Go. So for the slope going up, it would be 6 meters over 3 minutes, which is 2 meters per minute. For the descent, you would go down 6 meters, so -6 meters, and that was over 2 minutes. So that is -3 meters per minute. So the change in speed, yes, not for the first one, because that's over 3 minutes. It's for the second one here that's over 2. Okay? The change is 3 minus 2, so it's 1 meter per minute. Okay? You have to ignore the negative sign, because the negative sign is just talking about whether the plane's going up or down. Okay, so you're just looking at the speed change. That's a little weird, right? Because you think, oh, it's -3, I should be subtracting them. No, you shouldn't. The negative sign's talking about going up or down. Any questions? Okay, we're going slow. Next one, real quick. So, slow pitch team is hosting a banquet. The caterer has a setup fee of $500, and it's $5 per person. So the the cost of the banquet depends on the number of people. So the cost is going to be the dependent, and we'll use a capital C, and the number of people will be the independent, and that will be a little p for people. Okay, so right away do a depends on sentence so you can tell which is dependent and independent. Write an equation. So the cost equals $5 per person plus $500 for setup. What's the rate of change? It's $5 per person, and it represents the cost of a ticket, or the cost of a ticket, or the cost for each person. What would be the cost if 325 people attend? So substitute in. So P becomes 325. Plus 500. And it's going to be a big one. Go to your calculator. $2,125. Okay, so make sure everyone attends. Haha. Any questions? Okay, quickly read the graph, answer the questions. What's the domain? What's the range? The domain you can write is inequality, and also using your brackets. And then you can do the same for the range. So for the domain, x is between 0 and 12. So you put 0 and 12 inside the square brackets. Remember, it's a low value, comma, high value. What would be your range? Your range would be between, so you use your inequality, 0 and 600. And you would use square brackets because you're including those values. What is the rate of change? So you actually have a super easy triangle for you. It's made right there. This is 12 seconds and this is 600 milliliters. So go ahead and figure out M. 600 milliliters divided by 12 seconds. And it's negative 600 rather. So negative 600 represents negative 15 milliliters per second. What does it represent? The water is decreasing 50 milliliters per second. Now you could also say it's being drunk at a rate of 50 milliliters per second. You have to indicate that water is leaving the glass because it's going down. That's what the negative sign is telling you. Water is leaving the glass. Ashley? Oh, 12S, yeah. It's 12S. There you go, 12 seconds. So what are the axis-intercepts? What does it mean? So what's the y-intercept? What does it mean? What's the x-intercept? What does it mean? And then writing an equation. The equation would be y equals mx plus b. You found the slope. You know the intercept from the graph. So, super easy equation. What is it? What's your y-intercept? 600 milliliters. That's the starting volume. X-intercept, 12 seconds. That's the time to drink the water. Good. Then your equation, your slope is -50. That was calculated above. And your y-intercept you just found is +600. Super easy equation because you already found all the information.